So in fiber, this diameter of core is 10 to the power minus 6 meter, that is micrometer, which is the dimension of hair. And then there is a cladding, and the outermost part is known as jacket. So this is the basic structure of fiber optics. इसके अलावा थोड़ा सा हम लोगों ने पढ़ा न्यूमेरिकल अपर्चर. Numerical aperture NA. Numerical aperture NA is sin I theta E entrance, sin theta entrance, which is equal to N1 square minus N2 square. ये न्यूमेरिकल अपर्चर का एक फॉर्मूला हम लोगों ने पिछले लेक्चर में डिराइव किया था, ये मानते हुए कि ये कोर है और ये क्लैडिंग है जिसकी रिफ्रैक्टिव इंडेक्स N1 और N2 है, और इस कोर क्लैडिंग के एकदम बीच में दिस इज योर एक्सिस, और ये एक लाइट इंटर किया, दिस इज IE इंट्रेंस, दिस इज इंट्रेंस. तो ये इंट्रेंस यहाँ पे जा करके और फिर ये टोटल इंटरनल रिफ्लेक्शन फॉर्म करता है. दिस इज टोटल इंटरनल रिफ्लेक्शन TIR. तो इसमें N1 और N2, N1 and N2 where refractive index of core और N2 is refractive index of cladding. ये cladding का हो गया. और total internal कराने के लिए N1 must be greater than N2. N1 का मान N2 से ज्यादा हो तो हम इसको निकाल सकते हैं न्यूमेरिकल अपर्चर, और इसके ऊपर एक एग्जाम्पल कर लिया. इसके बाद हम थोड़ा सा आज इसका डिसएडवांटेजेस ऑफ फाइबर ऑप्टिक्स को डिस्कस किया. क्या है डिसएडवांटेज? तो पहला ये हम लोगों ने कहा इट इज यूनिडायरेक्शनल. इट इज यूनिडायरेक्शनल, या इसको कहते हैं मोनोप्लेक्स या हाफ डुप्लेक्स. हाफ डुप्लेक्स. और हॉट लाइन का कनेक्शन है तब इसको होता है बाई डायरेक्शनल, और बाई डायरेक्शनल करने के लिए या तो डुप्लेक्स करें, डुप्लेक्स मीन्स फुल डुप्लेक्स, या टू फ्रीक्वेंसी यूज करें. टू फ्रीक्वेंसी यूज करें तो होगा. देन इट इज से डिस्पर्सिव. तो डिस्पर्शन इज अ बिग प्रॉब्लम, और डिस्पर्शन के वजह से होता क्या है, टाइम, देयर इज अ टाइम लैग, है ना, देयर इज अ टाइम लैग. डिस्पर्शन की वजह से टाइम लैग होता है. एंड देन इट इज costly in connection and maintenance. मेंटेनेंस भी इसका थोड़ा महंगा होता है. और मेंटेनेंस में कई चीज आ गया, इलेक्ट्रिकल पावर भी हो गया, और दूसरा और लास्ट का होगा टेक्नोलॉजी ड्रिवन, है ना। टेक्नोलॉजी ड्रिवन की स्किल्ड वर्कर ही इसको हैंडल कर सकते हैं। यदि स्किल्ड वर्कर नहीं है तो इसको मेंटेन करना मुश्किल है, तो इट इज टेक्नोलॉजिकल ड्रिवन। अब इसमें आता है कि propagation of light in the fiber। तो प्रोपगेशन जो है दो तरह से होता है, वन इज मेरीडोनल रे के रूप में, और दूसरा होता है एसक्यू रे के रूप में। क्या है दोनों में मेरीडोनल का फॉर्म? यू सी, यदि ये कोर है, इफ इट इज कोर एंड हियर इट इज क्लैडिंग, है ना, दिस इज योर कोर एंड दिस इज योर क्लैडिंग, ठीक है। यहाँ पे भी इसी के साथ हम बना लेते हैं, ठीक है। तो अंदर वाला पोर्शन कोर हो गया और बाहर का पोर्शन ये क्लैडिंग हो गया, ठीक है, फाइबर है। अब जो रे है, इसके केस में रे ये पास करता है, दिस इज रे, मतलब रे का डायरेक्शन इस तरह से है, दिस इज रे डायरेक्शन। स्क्यू में डायरेक्शन ऐसे है, ऐसे, ये डायरेक्शन है रे का। तो दोनों में अंतर क्या है कि जब हम इसका डायग्राम बना रहे थे तो देयर इज एक्सिस, मतलब ऐसे यदि हम कोर कह दें और ये क्लैडिंग है, कोर एंड क्लैडिंग, सो दिस इज योर एक्सिस, दिस इज द एक्सिस। तो इसके अंदर इस पार्ट में यदि एक्सिस बनाए तो यहाँ पे तो क्लियर विजिबल होगा, दिस इज योर एक्सिस। उसी तरह से यहां पर भी क्लियर विजिबल, दिस इज योर एक्सिस, ये एक्सिस। तो टोटल इंटरनल रिफ्लेक्शन तो होगा ही, मीन्स द mechanism of propagation of light is total internal reflection, total internal reflection, TIR, this is TIR। यहाँ पे भी the mechanism of propagation of light is total internal reflection, है ना। अब जो डिफरेंस है, दोनों ही तो सिमिलरिटी है, डिफरेंस क्या कि मेरीडोनल में ये एक्सिस को क्रॉस करता है, ये एक्सिस को क्रॉस नहीं करता है ना। टोटल इंटरनल रिफ्लेक्शन विथ क्रॉसिंग द एक्सिस, with crossing the axis, with the crossing the axis, यहाँ पर without crossing the axis, without crossing the axis। तो डायग्राम के बाद का ये पॉइंट, और इसके बाद नेक्स्ट पॉइंट ये है कि द पाथ ऑफ these rays, the path of these rays inside fiber is like a sawtooth wave, like a sawtooth wave. और वेव शेप क्या होगा sawtooth का? sawtooth का वेव शेप समथिंग लाइक दिस. Something like this. What about in skew ray? The path of these rays inside fiber is like हेलिक्स के रूप में. और हेलिक्स के रूप में यदि पाथ है तो ग्राफ क्या होगा? दिस इज योर ग्राफ. हियर द ग्राफ इज here the graph is something like this. This is your helix like shape. तो ये दो डिफरेंस हो रहा है मेरीडोनल रे और स्क्यू रे में, जो लाइट की प्रोपगेशन को रिप्रेजेंट करता है फाइबर के अंदर. नेक्स्ट इज टाइप ऑफ क्लासिफिकेशन ऑफ फाइबर. Classification of fiber, or classification, it is based on the various parameters. It is based on the various parameters. जैसे इसका मोड ऑफ प्रोपगेशन है, जैसे इसमें किस तरह के मटेरियल हम यूज करते हैं, जैसे किस मोड में इसका प्रोपगेशन हो रहा है ना. पहला है मोड. फर्स्ट इज मोड ऑफ प्रोपगेशन. मोड ऑफ प्रोपगेशन फर्स्ट है सिंगल मोड, और दूसरा है मल्टी मोड. और इसके लिए एक नॉर्मल फ्रीक्वेंसी है, दैट इज वी पैरामीटर, जो हम आगे डिफाइन करते हैं. वी पैरामीटर से इसको डिफरेंशिएट करते हैं. सिंगल मोड का मतलब कि एक ही ये कोर है, तो कोर से एक वेव जा रहा है, दिस इज सिंगल मोड. और मल्टी मोड क्या मतलब कि देयर आर मेनी waves something like this. This is the main. Then this is on the basis of refractive index. First is step index fiber. This is SIF, or second is graded. GIF. तीसरा है ऑन द बेसिस ऑफ SIP. On the basis of shape, first है on the basis of shape plane, second curve, and third is conical. Fourth is on the basis of dispersion. On the basis of dispersion, first has shifted dispersion, or second have flattened. And then on the basis of polarization, last one is on the basis of polarization, the maintaining fiber. First is polarization, maintaining fiber, or second one is mode by references. तो इसमें जो मोड ऑफ प्रोपेगेशन है, मोड ऑफ प्रोपेगेशन एज इट इज शोन, और दूसरा है रिफ्रैक्टिव इंडेक्स का प्रोपेगेशन. तो हम लोग वी विल डिस्कस अबाउट द रिफ्रैक्टिव इंडेक्स प्रोपेगेशन इन डिटेल. सो दिस कैन बी on the basis of classification on the basis of the refractive index. So first is step index fiber, SIF, and then the second is graded index fiber. तो फर्स्ट पॉइंट है द structure of the step index fiber is the refractive index. If we say this is your core part and here it is the cladding part. This is the core part and here it is the cladding part. So the refractive index vary something like this. Vary something like this. So this part is R, this part is R. Here it is origin, this is origin, and this is A. Here it is origin, this is A, and this is refractive index NX. So this value is N1, this value is N1, and here it is N2. This value is N2. This value is N1. So N1 is greater than N2. This is N1 and this is N2. And this portion is definitely it is core and above is cladding. Above is cladding. This is your cladding and here it is core. Similarly, if we say this is your core and here it is the axis. This is x-axis and this is the core. And this portion is cladding. So refractive index is varying like this. Refractive index vary like this. This is N1 and here it is N2. This is N of X, refractive index. Axis, y-axis is refractive index, x-axis is the radius axis. Here it is X, R radius. And this part is A is diameter, radius, yeah, say its length. So in graded index, if we have this one is this is here we have this, this, and that's why in mathematical function nx is equal to n1, n1 x is less than a and greater than minus a. This is say minus a, greater than minus a. Or here it is n2 x mod is greater than a. X mod is greater than a. In this case, here it is the structure and this mathematics. So nx is equal to, in this way, n1 minus r by a ka whole square. And this is 1 by 2. And here it is n2. This r is, this is your a and here it is minus a. So either you can say x, yes, we can call it x by this. And here minus a x plus a. In this case, mod x is greater than a. Mod x is greater than a. So at a, at x is equal to 0, suppose at this point. So this 1 minus 1 is 0 and this n is 0. Then it is of the kind of the original part that we have find here. Now the third point is there are many paths. There are many paths for the light signal. There is many paths for the light of signal. In this case, for one light signal, only one path is there. Only one path is there. In this point, so dispersion is considerable. Dispersion, that is time lag, is considerable here. But in this case, dispersion, yeah, time lag is minimum. We can say it is reduced form. It is the reduced form. Or path is in straight. Path is in straight line. Here the path is curved. Path is curved. How the path will be? If you want to define the path, so we can draw this is core. This is the core. Then the path is the path axis. One is axis. Other path is this path, which is curved path that is moving. The similar path is here. If the path is not far away, then this path is also here. So in this way, what we find this path the path. So these have the same profile, and that's why dispersion is minimum. That's why dispersion is minimum. Dispersion is minimum. But in path, in the case of the step index fiber, in case of step index fiber, this is the core, and here it is the axis. So once the path is Then another path is and then another ray has different path. So the paths are different in this way. In this way. And that's why the path is, we can call the path is a straight line. The path is a straight line. So these are the 5 points. On the basis of these 5 points, we have defined step index fiber and graded index fiber. Step index fiber and graded index fiber. And this is the very important, concept that we have used in case of the फाइबर ऑप्टिक्स. दिस इज वेरी इंपॉर्टेंट और आप देखेंगे तो हर साल इसमें से कुछ न कुछ क्वेश्चंस जो है आते रहते हैं. So let us take some numerical problem on the basis of the numerical aperture and all. It is examples. The first example is an optical fiber has a numerical aperture NA is 0.02 and cladding refractive index is 1.59. So determine first acceptance angle for fiber and water, and then the second is critical angle. Critical angle of the core cladding surface. Solution. The Snell's law, expression is sin theta I C is equal to N2 upon N1 and NA is equal to under root N1 square minus N2 square. So we have 0.2 whole square is equal to N1 square minus N2 square. So N1 square is 0.04 minus, or this is N2 is plus square, that is 0.04 plus 1.59 whole square, and then it is 2.56 is N1 square. So N1 is equal to 6. This is the core. Now here the angle is, now sine theta IC is N2. N2 is 1.59 and this is 1.60. So this value is 0.99 and this is sine theta IC. So theta IC is sine inverse 0.99 and this is approximately 84 degree. Theta IC, that is acceptance. That is acceptance angle. This is the critical angle for core cladding interference. Critical angle. The acceptance angle for the water, then we have to see the water has refractive 1.33. Water has refractive index 1.33. So on the basis of 1.33, we have to find out the theta on the basis of our previous formulation. What was the previous formulation? That is sine theta I and sine theta R. This sine theta I and sine theta R has the values, and that values are something like sine theta A is equal to under root of n1 square n2 square upon n0. That is under root of 1.6 square minus 1.59 whole square divided by 1.33. And then we take the inverse of that, then we will find the acceptance angle. Now, the next example, is when we find the compute the numerical aperture in A and acceptance angle of an optical fiber from following data. What following data? N1 of core is 1.55. N2 cladding is 1.50. So solution, the fractional change in refractive index of core and cladding is delta. That is, delta is equal to N1 minus N2 upon N1. So this is 1.55 minus 1.50 divided by 1.55. 1.55. So this value is 0.05 upon 1.55, then it is 0.03226. This is 3 T. The numerical aperture is given as NA is equal to N1, this is 2 delta. And this is 1.55 N1, 2 into delta 0.03226. 0.03226. And this value is 0.394 in A. NA value is this much. Similarly, we can calculate the other. And if we try to draw the profile of numerical aperture with the angle, incident angle, then we can draw the very clear diagram with the variation of numerical aperture in case of the you can take this as note. The plot of NA. Suppose this is the x-axis, and on this x-axis we have acceptance angle, and this is numerical aperture NA. Numerical aperture is NA. So we can have the straight line plot. The straight line plot is something. This is 30 degree. This is 20 degree. And here it is 10 degree acceptance angle. And this value is 0.5, 0.4, 0.3, 0.1. And this is 0, 0. So what we find? Okay, the sine theta NA is sine theta A acceptance. So sine of 30 degree is 1/2, that is 0.5. So NA is 0.5. NA is 0.5. So we can have the plot in this way. Plot in this way with the help of the numerical aperture and acceptance angle. Now we have the value. We have the value which are prominent regarding the variation of refractive index. So the materials used in the formation of core and cladding. Core and cladding. First is core, second is cladding. Cladding is low value and core is high value. High value of refractive index. So there are some materials which are used and these materials are fluorine. the fluorine and boron oxide, that is B2O3, reduce the refractive index of SiO2, silica. So what we find, if there is a silica oxide, SiO2, and this is the mix with fluorine and B2O3, so reduce the refractive index, while the phosphorus pentoxide P2O5, phosphorus pentoxide, and germanium oxide GO2 will increase the refractive index of SiO2. So what we find, if we want to increase the refractive index of the materials, then we use the phosphorus pentoxide and germanium oxide in SiO2, which increase the refractive index. And if you want to decrease the refractive index, then we have to use boron oxide in SiO2, silicon oxide, yes, silicate. So this will decrease the refractive index. And if you want to graded N, that is variation, something like this, variation. So we have to increase the concentration at this point. Increase the concentration of what? Phosphorus pentoxide and germanium oxide. We have to increase the concentration over there and decrease the concentration over outer side. Then it will give the refractive index of the varying refractive index of the material. So this is all about the today discussion regarding this fiber. Now the next topic that I would like to discuss is loss in the fiber optics.